All right, thanks, Kate. And our final presentation today will be by Sarah Young from the Carnegie Mellon University Libraries and Eliza Grames from the University of Nevada, Reno. Their presentation is titled Increasing Access to Evidence Synthesis Methods Through Tool Development and Capacity Building.
Great, thanks so much, Trevor. So as Trevor mentioned, I'm Sarah Young. I'm a social sciences librarian based at Carnegie Mellon University in Pittsburgh. And my co-presenter is Eliza. Introduce yourself if you'd like.
Yeah, I'm Eliza Grames. I'm a postdoc at the University of Nevada, Reno, where I'm working on insect and bird conservation and climate change.
Great, thanks, Eliza. So as a librarian, I support quite a few evidence synthesis projects across a lot of disciplines. And today we're going to be talking about increasing access to evidence synthesis methods through tool development and capacity building. So next slide. So tools and methods, of course, can be built and developed for any step of the evidence synthesis process. But this presentation is really going to focus on the information retrieval phase of this kind of work. And information retrieval is really a foundational step that is essential to pretty much any type of evidence synthesis, from systematic reviews to evidence and gap maps, scoping reviews, etc. And as a librarian and an information specialist myself, this is also the step that I'm typically most involved in when I support or conduct evidence synthesis projects. Next slide. So effective information retrieval really lays the foundation for all subsequent steps in evidence synthesis. And it's really the search that forms the initial set of studies from which ultimately the included studies in a review are drawn. And so it's really critical ultimately to the conclusions and recommendations that result from a review. Next slide. There are a lot of challenges involved in the information retrieval phase that any searcher encounters in pretty much any evidence synthesis project. And the decisions made around these challenges can really impact review findings and potentially bias the eventual included studies in a review. So for example, we know there's a general lack of standardized terminology in most fields. And so you can't simply rely on searching for one or two commonly used terms, but you really need to include many possible terms to account for the variation in ways researchers in different disciplinary, geographic, or linguistic contexts refer to a concept. Also, determining where to run searches, such as which databases, websites, or search engines to use, is also important and could, for example, impact the geographic comprehensiveness of a search. Using search terms not just in English, but other languages can help mitigate the language bias in the published literature. And this can be really challenging if the person designing the search does not have fluency in a language that might be important to a particular review. So how do we potentially address these challenges with innovations and methods in technology? And I'll let Eliza take it from here.
Yeah, thanks, Sarah. So I think this whole session has kind of been about tools and methods and what the challenges are. And so we kind of put together this conceptual diagram to ask, whether these challenges require a new method or a tool. And so in this case, the challenge is choosing search terms. And, it's not clear whether there's methods out there for this. So, like Elka described a lot of the work that they did with text mining, but it's not a specific method for choosing search terms, which is part of the challenge. And so when we're thinking about how to best choose search terms for a review, it's really, we need a conceptual solution before we can move on to making methods or code. And so that's where I kind of started from at one point during my dissertation, trying to figure out what is the solution to this problem? How do we choose search terms in a way that's quick and objective, reproducible? And so I'm going to just briefly present an example here, and to give you a little bit of context so that the words make sense, I'm going to be talking about birds in fragmented forests. So on the left here, this is a larger forest, this is a smaller forest. it's fragmented because they're separated by this probably power line. And this is a bird that would prefer to be in the large forest, not the small forest. And so if I want to find a bunch of studies related to this topic, there's a whole bunch of different terms that I could possibly search for. And so conceptually thinking about this, what you could do is go out, search for some words related to this. So I could say, okay, this is a bird, it's sensitive to the area of a patch, it doesn't like habitat fragmentation, so I could search for those words and get back a bunch of articles that used those terms. But I know that's not all of the terms people could use to describe this topic. And so what I can do then is go through all of the titles and abstracts and keywords for those articles and pull out potentially good search terms. And so that's what's highlighted in yellow here, is I could go through and say, okay, patch openness, that might be related, apparent area sensitivity, here we have larger habitat patches, patch size. And so those aren't terms that I searched for initially, but they're related to the topic. And so we kind of, need a way to go through all of these articles and pull back what those related terms are. And so that's kind of the conceptual framework. So I was like, okay, this will work, but it's not really a way to implement it. And so with that as the conceptual solution, we still need, methods to do this and then code to automate it. And so the method that I decided to use is a keyword co-occurrence network. And so each keyword, which were those things that I highlighted in yellow in the abstract, is one of these circles. And then each line between them is a co-occurrence. So if two words appear in the same abstract, they get a line between them, and that means that they've co-occurred. And then we can use various ways to find a cutoff and take just these terms in the center of the network that are the most important. So it's like, okay, now we have a conceptual solution, a method, and there's a whole bunch of really, really messy code that I wrote that's probably somewhere in a GitHub archive that isn't really easy for anyone but me to use, because you kind of have to read my mind, and I didn't put comments in it, and none of the names of the functions make sense. And so it's not really that easy for other people to access this, even though I'm like, okay, guys, I have a solution. And so that's kind of the next step in making evidence synthesis methods easier to access, is turning them into an R package or a different type of tool in a different language. So I made the R package litsearchr. I'm not going to go into all the details, but essentially it's an R package that implements that solution for finding search terms. And the way it works is it does the whole thing that I just described with the conceptual model. So you can import results and then remove the duplicate articles using the R package synthesizer. And then it pulls out all of those terms and suggests them. So based on the methods that it uses, it says, here's some possible terms you can consider. And then you can go through and manually group those. So for the first three, I was like, okay, yep, that's a bird, that's a bird, that's a bird. This one, no, I'm not going to use it, it's too broad, and so on. And so you get back all of these terms, and then you can feed them back into litsearchr, and it will write a full Boolean search, because deciding where to truncate, when to truncate, what to put in quotes, it can take a while, and any typos lead to some problems. And so it will do that, and I don't expect you to be able to read that. And then, as Sarah was mentioning, it's really hard to choose languages to search in. So it also will suggest languages based on how many articles or how many journals actually are published in languages other than English for that topic. And so here, it turns out that Dutch was very relevant, so I had to translate the search into Dutch. I don't know if these are the best terms to use, but it'll at least help me pull back some relevant articles. And so if you want to learn all about the actual methods underlying it, not just the overview, you can read about it in Methods in Ecology and Evolution. And so, at that point as a developer, I'm like, okay, that's done. I made a package, everything's great. But that doesn't necessarily mean that end users can actually access the methods implemented in that. So I'm going to turn it back to Sarah to talk a little bit about that.
Great. So one of the barriers to using these tools, and I think we've heard this in our other two presentations as well, is just a lack of specialized skills, largely coding skills. And there really is quite a steep learning curve here when it comes to learning how to code, both in terms of coding languages and also the associated software involved. And to some, this can really feel like an insurmountable barrier, especially with those folks with no coding experience or maybe minimal bandwidth or resources available to learn. or people working in an environment where there's few people around that have or need this skill. Next slide. So how do we address the skill gap? We know that just learning some basic coding can really empower end users like librarians and researchers to use these many open source tools that are being developed for evidence synthesis, like litsearchr. And while there's many free video tutorials, learning platforms out there, this sort of asynchronous, self-motivated learning isn't necessarily right for everyone. Instead, learning with others in sort of a synchronous, live, or online environment can really be more effective in some cases. And especially if that learning environment is supportive, if it's practice-oriented, and if it offers immediate applications to one's work, this can really facilitate long-term retention of skills and knowledge. Next slide. So this is where the Carpentries comes in. The Carpentries is a nonprofit organization that aims to build global capacity for coding and data science skills. Carpentries really focuses on reproducibility and open source tools, and all Carpentries curriculum is built and taught by the community and is made freely available online. Carpentries project is comprised of data carpentry, software carpentry, and library carpentry. And together they provide really hundreds of hours of curriculum to teach R, Python, and other open source data science tools and methods. Next slide. So litsearchr really clearly presents a great opportunity to improve search efficiency and minimize term selection bias, both of which are concerns for very busy information specialists and librarians like myself, who support evidence work in many different contexts, as well as researchers doing this kind of work. But probably most librarians don't have coding skills, and so that can present a real barrier to using something like litsearchr. With library carpentry in particular, we saw an opportunity to build coding capacity and knowledge amongst this key stakeholder group in evidence synthesis work by developing a Carpentries lesson in introductory R in an evidence synthesis context using litsearchr. And the credit for this idea really goes to Amelia Callagher. She's a social sciences librarian at Cornell University. This was really her idea. Brought Eliza and myself together as well, and she developed a lot of the content as well. Next slide. So this is probably, I think, the first evidence synthesis related Carpentries lesson out there, and it was piloted to a group of virtual learners in August 2020. And it provides learners with an immediate application of coding to their work, conducting and supporting evidence synthesis. Live coding, hands-on exercises, and a well-supported learning environment are all hallmarks of a Carpentries workshop. Next slide. So the lesson is now freely available. It's up in the Carpentries incubator, and it's open for anyone to contribute and help build on. There's really a lot of opportunity, I think, with Carpentries to build other lessons related to evidence synthesis using, many of the packages that come out of, for example, the hackathon. And I really encourage folks to learn more about the organization and consider contributing. Eliza.
Yeah, so that's one really good way to make R packages easier for people to access is to actually provide training in R. But then there's one further step to making things easier to access, which both Elke and Steve and Trevor all touched on, which is to make a GUI, so a graphical user interface that I use. So just call it like a click and point, so you can just click and point and not have to do any coding. And so it's really easy to do this for R packages using Shiny apps, because you can just write all of the code in R and then output a graphical interface. And so I did this for litsearchr because I kept, thinking like, oh, it's great, it's out there, it's an R package, but there's so many people who can't actually get into R. And so it does everything that litsearchr does, but you just can do it by clicking and pointing. So in litsearchr, if you're using it as a package, you would type import results. Here you can just browse and upload a file. So you can upload a bunch of bibliographic data. You can remove duplicates just by clicking. And then it'll extract keywords using the exact same logic. It spits out all the potential terms that you can see here. And then you can look at the network, not the most useful part of the GUI, but it shows you kind of that, like, what's going on behind the scenes. And then it'll suggest search terms based on how important they are in the network. And there's all sorts of options to fiddle with this and decide, you know, how important should they be before you'll consider them. And then in addition to just selecting search terms, it lets users write Boolean searches by uploading everything, translating it, doing all of that. And then, also checking the comprehensiveness of a search. So is it retrieving all of the articles that you think it should be retrieving? And so, you know, going from this challenge of how do we actually find search terms through a conceptual solution to a method to a package to click and point, you know, it's all just making it easier for people to access these tools and making it easier to do really quick evidence synthesis. And so I'm going to turn it back to Sarah to wrap us up.
Great, thanks, Eliza. So yeah, just to basically wrap up, we talked about identifying challenges and limitations and determining whether a new tool or method is needed, or if an existing tool or methods need to be more accessible. Communication between end users and developers is critical. I think we've heard this from other presenters as well, especially in identifying needs and accessibility barriers. We focused on skill accessibility in this particular talk, but there's really a huge range of accessibility considerations, and a GUI isn't necessarily going to address all of those. So certainly keeping other types of accessibility in mind. And ultimately, we need more communication and collaboration between users and developers, and end user needs should be taken into account when really from the early stages of tool development. So we're really looking forward to hearing some of the discussion on these topics about this, and really thinking about ways that this sort of collaboration can be facilitated. So we will go ahead and turn it over to Alex for discussion questions. Thanks, everyone.